For part one, we will talk about describing center and location. First, we're going to talk about the mean, and then we're going to talk about the median, and then the mode. So in terms of sort of the orienting approach to this discussion, we're going to talk about the study of popularity among kids. So suppose you're a social psychologist and you want to examine what makes kids popular. So you're looking at elementary students. And then what you do is you administer a survey to a sample of 478 students in grades 4 to 6 in the United States. And then you decide to ask two questions about popularity among these kids. One question has to do with the students' own goals, what they want to accomplish while at school. And another question has to do with about what makes kids popular, what they think the attributes of being popular really consist of. And then you also gather additional data on gender, grade level, and the school district location. So this is an actual survey that was administered by social psychologists. This first question has to do with students' goals. And the question is, what would you most like to do at school? A, make good grades, B, be good at sports, or C, be popular. This was actually given to a sample of children in an elementary school. The second question has to do with this sort of conception of popularity. Which of the following would make you popular among your friends? And the students are asked to rank in order. So the students are asked to rank making good grades, having lots of money, being good at sports, or being handsome or pretty. So the students are given those options and they have to say, okay, well, making good grades, I'd put number 1, then maybe being good at sports, I'd put as number 2. They're asked to rank these 4 options. And in addition to these 2 questions, the social psychologists also gathered other data about the students. This is what the data set looks like. So you can see in this data set, there is an N of 478 children, so the sample size is 478. That means that there are 478 rows or cases or observations to this data set. And then we have several variables. So the variables include age in years, gender, whether the student is a boy or a girl, so those are the 2 levels of that factor. We also have this variable grade level, and this is the student's grade level. They're either in the 4th, 5th, or 6th grade. We also have this variable for location. So we have information on the school district where the student is located. Is the school district rural? Is it suburban? Or is it in a city? Is it urban? The other variables we have include goal. So this is that first question that we just talked about. That has to do with the student's own goal in school. And the variable is coded such that the student is either going to have a goal of having good grades, of being popular, or being good at sports. And then we have these 4 other variables that encode the information about this ranking question, about what popularity consists of among elementary school students. So grades is simply a ranking of importance of grades and being popular. Sports is the ranking of the importance of sports. Looks is the importance of good looks or being pretty. And money is the ranking of importance of having money for being popular. And so each student, so each row of this data set, you can see each student ranks one of these variables as 1, another variable is 2, and another variable is 3, and another variable is 4. So each value for each of these variables is 1, 2, 3, or 4. So it's a numerical discrete variable, each one of those. So just to review these kinds of variable types, this first column, it's a discrete variable because you have these sort of non-negative counting numbers that really constitute the information for that first column. The second variable is categorical. It's nominal, so there's no inherent ranking to whether you're a boy or girl. The next variable is discrete and it's numerical because you're not 5.5 grades. You're 4th, 5th, or 6th grades in terms of the information in this data set. The next variable is categorical, it's nominal. There's no inherent ordering to whether a school is in a rural, urban, or suburban district. The goals variable is also categorical, it's nominal because students are just asked to say what their goal is, but we're not beforehand saying that one goal is necessarily more important or has a higher ordering beforehand. That's why we're conducting the survey. So that variable is categorical, it's nominal. And then these last 4 variables which encode the information about ranking these different attributes and what makes a student popular, those are nominal variables, numerical variables, but they are discrete numerical variables, meaning they are non-negative counting numbers. So how do we describe this numerical data in this data set? Because in this data set, many of our variables they're not categorical. We have a few categorical variables, like the gender variable, but a lot of the variables, a lot of the columns are numerical, especially these ranking variables. So how can we describe numerical data? Because last week we talked about categorical data, so we know how to create tables and we know how to really create bar graphs and pie charts. But numerical data, they're a little bit different because they can take on many different values. So to really describe and understand numerical data, we focus on, in addition to graphical techniques, which we'll cover soon, we talk about the different kinds of numerical summary measures. These include measures of center and location. So the center is sort of where the center part of a variable is. So these are measures such as the mean, the median, the mode. We also talk about measures of location, which include quartiles and percentiles. And then we also can think of it in terms of measures of dispersion or variation or spread. These include the range, the interquartile range, which is that middle 50% of the data, and also these things called the variance and standard deviation, which we will cover in just a moment. So this is sort of an overview of the different summary measures we're going to cover. Right now we're going to focus on measures of center and location, in particular the mean. It's a very commonly used measure of central tendency. When you try to understand what the typical value is, where the center part of a numerical variable is, we often focus on the mean. So let's talk a little bit about the notation that we often find useful when we talk about the mean. Suppose we collect n different observations for a variable we call x. It's useful to write out these values or observations with subscripts. So if you have, say, 3 data points, 3 observations, it's useful to label each observation with an x and a subscript. So you might have x1, x2, x3. That refers to 3 different observations. And then x subscript 3, that refers to the 3rd data point. This is just a very useful way of concisely describing the observations in our data set. So you can just say, well, what's the value of I equals 3 or x subscript 3? You can immediately refer to that data point. So here's an example of using this notation. This is, in some sense we've already covered this, but I think it's useful to talk about this again. This is just looking at, if you have this small data set of 5 rows or 5 observations or 5 cases, it's useful to index these observations. So the observation x subscript 1 is simply 145. That's that first row. X subscript 2 is that second row, which is 98, and so on and so forth to x subscript 5, which has a value of 210. So this is just, again, we like to keep track of our data points of our observations so that we have sort of a concise way of talking about our data. So the mean or average weight in this data set, this toy data set, it can be generically described as adding up each of those different observations divided by the total number of observations. So that's simply the mean is x subscript 1 and so on and so forth. X subscript 5, you're just adding up each of the observations and dividing by the total number of observations or the total sample size. So in this case, when we add up all the weights, we get 660 pounds. So if you add up all these 5 observations, and then we want to divide by the total number of observations, or n, that's the sample size, and we get this average or mean of 132 pounds. So when we talk about the mean or average, it means the same thing. In statistics, we like to call the average the mean, just because we like to be fancy and use a sort of adult language now that you're taking a real statistics course. So the mean of this set of observations is 132 pounds. You can kind of think of this as the typical person in this data set. The typical person in this data set is 132 pounds. Now, when we talk about means in statistics, it's useful to distinguish between a sample mean and a population mean. So earlier, when we talked about samples and populations, we mentioned that in statistics, we use a slightly different notation whether we're talking about a sample of data versus a population of data. If you recall, a sample is some subset of a population, and statisticians and data analysts, we often work with samples because they're just much easier to collect. They're much cheaper. When you have a population of data, it's very expensive. You have to conduct a census. So a lot of statistics is about taking a sample from a population and saying something about a population based on that sample. Now, I say all this because this difference between a sample and population is very, very important in statistics. And so we like to keep the notation separate for whether we're dealing with a sample or a population. In a similar way, we like to distinguish between a sample mean and a population mean. So if your data set, if your set of observations is a sample, then we call the mean x bar. Okay, so it's just an x with a line over it. This is just by convention. This is the notation that we use. If your data set is a population, then we call the mean mu. This is a Greek letter mu. And I think the important point is that in general, when we talk about population parameters and versus sample statistics, the population parameters are expressed in Greek letters typically, and the sample statistics are represented in Latin or Roman letters. So in this case, we in fact do use Latin or Roman letters for the sample mean, x bar, and we use a Greek letter for the population mean, otherwise called mu. In a similar way, the formulas that we use to calculate a mean from a sample versus the mean from a population, the formula is actually the same, but the notation is a little bit different. So it's useful to look at the notation just so that everything is crystal clear. This is how you calculate the mean of a sample. You just take up all the observations, you add up the observations, where x subscript n is the last observation in a set of observations, where n is the sample size. So you add up all the observations, and then you divide by the total sample size, and that will give you x bar, the sample mean. Now the little n, when we talk about the little n, that refers to the sample size. That refers to the total number of observations in a sample. The mean from a population has a slightly different notation. So we use capital N to refer to the size of a population. It's the total number of observations or data points in a population. So if you conduct a census of the United States today, roughly the population is about 320, 330 million. So the N here would be, if you took the average of everybody in the United States of some variable, let's say weight, then that population size will be capital N. So you take up all the observations, you add them together, and you divide by the total population size, and that will give you this value of mu. Okay, so you can see that the actual calculation is the same. You're just adding up the values of the different observations and dividing by the total size of the population or the sample. If it's the population mean, we call it mu. If it's the sample mean, we call it x bar. So when we talk about the mean, there are certain advantages and disadvantages. As a measure of central tendency, the whole point of the mean is that you have all these observations, but you want to kind of reduce the sort of information to just a typical person, typical observation. So in our example of 5 different weights, you just want one number, sort of the typical weight of a person in this data set. Well, the great thing about the mean as a measure of central tendency is that it's representative of all the data points. So it includes information from all the observations. All observations are put into the mean to represent the typical part of that distribution. Another advantage is that you will see the mean everywhere. It is used when you continue to take statistics courses and apply data analytic methods, the mean is everywhere. It's a very, very popular measure of central tendency. So you will see it a lot. It's very useful to know. There are a few disadvantages. The main disadvantage of the mean is that it is sensitive to extreme values. Extreme values in statistics are also called outliers. Another way to put it is that the mean is not robust to extreme values. It is not robust. So let's look at an example of this. So in this first calculation, we have this set of observations of 1, 2, 3, 4, and 5. So we have 5 observations, and we divide by the n, which is 5, because you have 5 different data points. So the average of this first little data set is 15 divided by 5, which is simply 3. So that's the mean of this set of observations. Now what happens if we just take that last value of 5 and just double it? Okay, we're just making it a slightly larger value. In other words, we're making it an outlier. Relative to 1, 2, 3, and 4, 10 is pretty large. So when you add up 1, 2, 3, 4, and 10 and divide by the n, which is 5, you get 20 divided by 5, or 4. Now what happens is that just changing that one data point, that one observation, it alters the mean quite a bit from 3 to 4. So the mean, because it includes all the observations, it's actually sensitive to just changing one data point. You can change one data point and it'll shift the mean up or down. So in this case, 10 is an outlier, and the mean is sensitive to outliers. Now, so let's look at our actual example of popularity in this elementary school. If you recall, in this data set, we have 4 numerical discrete variables, and these variables have to do with what children think is important for popularity. A natural question is, for each variable, grades, looks, money, and so forth, what is the mean ranking for each variable? In other words, what do students think on average is important for being popular? Do kids think that having money is important? Do they think being good looking or handsome or pretty is important? Well, one way to really do this analysis is just to calculate the mean ranking for each variable. So before we continue, I think it's always important when you do a bit of data analysis to just sort of pause and say, what do I think I will find? Because the cool thing about data analysis is that often you'll be surprised. But you have to make sure that you have some expectation about what you're going to find so that you actually can be surprised. So take a moment and think about what you think we will find in this study. So let's go through the results. So we're looking at these last 4 variables of this data set that have to do with the ranking of what kids think is what makes kids popular. So we have this grades variable, and we actually would use statistical software, but I show you the notation here just so that you know that when you use statistical software, you get the same result. All we're doing when we use statistical software is we're adding up all these values. Now, you wouldn't actually have to add up all 478 values, but you could if you had enough time. That's what makes computers great, though, because computers can do this very quickly. All the computer's doing is, in essence, is it's adding up all these values and dividing by the total sample size. When we do that, we get this value of 2.62. That's sort of the average ranking for the grades variable. If you recall, a value of 1 means that kids rank it, number 1 is the most important, and a value of 4, they rank it least important out of the 4 categories. So 2.62, the lower the number, the higher the ranking. If you look at the sports variable, meaning how do kids on average rank the importance of sports and being popular, we take the average of that, we get 2.09. Again, all we're doing is we're taking up all the observations, all the data points, and we're dividing by the total sample size, which is 478, and we get 2.09. For the looks variable, so the importance of being good looking or pretty, we get this mean of 2.1. So on average, students rank having looks as 2.1 on average. And then for money, we take the average of that and we get 3.2. So that's the average ranking for the importance of money in being popular. Let's recap the popularity ranking for this data set. So for this data set, for each of these 4 ranking variables, a lower mean implies a higher ranking, while a higher mean implies a lower ranking. So the lowest is money. The average for the money variable, the average ranking is 3.2. For grades is 2.62. For looks is 2.1. And for sports is 2.09. So if you want to be popular in school, if you have kids and you want your kids to be popular in school, tell them to play sports. If we were to use the mean as a measure of central tendency, out of these 4 variables, the sort of lowest mean, meaning the value closest to 1, the highest ranking, is in fact sports. However, that's not the only measure of central tendency. There's also the median and the mode, which we will cover in just a moment.